Alright, so last chapter we talked about the simple linear regression. And next we'll talk about the multiple regression. Alright, so let's do a simple review about the simple linear regression. Right, so we say we need to randomly select a sample, right? And then we want to use the sample to estimate the population. So based on the sample, we can ask the jump to get, we call it is simple linear regression equation, right, which is y hat equals to b0 plus b1x. And correspondingly, for the population, we have the population linear regression model. So we have mu of y equals to beta 0 plus beta 1x, right? So for this kind of analysis, we say we use y hat to estimate the population mean of y. We use the samples intercept to estimate the population intercept. Right, we use b1 to estimate the population slope. Right? Okay, so for the whole process here, we call it is simple regression. Right, so why we call it is simple regression? Because it is simple. So that means we only have one explanatory variable, which is our x, right? And we have one response variable, which is our y, right? So we try to find the relationship between x and y, so that we say the x will affect the y. So for our goal of our regression is always to make the prediction about the response variable, right? So the simple regression is to make the prediction of y just based on one explanatory variable. But actually in the real life, one explanatory variable may be not enough to make the accurate prediction of y. So for example, in our old example, right? So we say we find the beer's price will affect the number of packs beers sold in the store, right? So we say the price will affect the sale. But actually there are some other factors will affect the response variable, right? So for example, maybe the average yearly income of that state or about that location will also affect the sale, right? Nobody knows, right? And also maybe the location of the store will also affect the sale, right? So we have many other potential factors will affect the response variable. So let's make another example. We say when we want to buy a house, then the house price will be affected by a lot of influencing factors, right? So we say, let's say number of bedrooms will affect the house price, right? And number of bathrooms of a house will also affect the house price. For example, the total number of total square feet, let's say this, right? The total area, square feet, will also affect the house price. So something else like the living area, right, will affect the house price. So for example, number of fireplace will also affect the house price, right? So some of them may have strong relationship between itself with the house price. Some of them may not have that strong relationship with the house price. But actually, every one of them should have some effects to the response variable house price, right? So now we will not only focus on one of them, we will use the combination of these effects to make the prediction about the response variable. So these ones are all explanatory variables. So since when we call it is x for the simple regression, now we want to add more explanatory variables into the regression. So we call, maybe this one is x1, this is x2, x3, x4, x5, and maybe others, right? Okay, so then we'll talk about what is multiple regression. So remember, I said in the class, we say any regression with the goal is make the prediction of the value y, right? So actually our goal is always to make the prediction of the response variable. But for simple regression, we only based on one explanatory variable we call x. But for multiple regression, we have k. We just define a k, right? K explanatory variables. Right, so if you want to combine these k explanatory variables effect to make the prediction of the y, then this process will be called multiple regression. Alright, so let's look at an example. We say about the house price, right? So how exactly does the Zillow.com figure the worth of the house, right? So actually what they use is just a multiple regression model. And then we say the price of a house has many influencing factors. Simple regression with only one predictor may not be that powerful anymore. We want to expand the power of regression model by taking more predictors into account so that more predictors contribute to the model. So now let's look at what if we just use one explanatory variable to make the simple regression model based on the data. Right, so here I have a sample of 1,057 local houses. Right, so let's look at the data. Alright, okay, so we have totally 1,057 houses. Alright, and then for each house, we have the corresponding house price, the living area, the number of bedrooms, number of bathrooms, number of fireplaces, and the age of the house. Alright, and then let's try the simple linear regression. We say, okay, I think the number of bedrooms may have strong relationship with the price, right? So let's try this. So we say analyze and then fit y by x, right? And then choose bedrooms as my x factor, price will be my y factor, and then click OK. So this is the scatter plot, right? Okay, so based on this scatter plot, is there any different thing you see? The number of bedrooms, you cannot have 1.2 bedrooms, right? You cannot have 2.6 bedrooms. So number of bedrooms will be just the integers. So it's a little bit difficult for you to look at whether there is a linear trend or not, right? So for this case, we will generate the box plot, right? Okay, so since they are integers, right? Okay, and then how to create the box plot, we click the graph, right? And then use the graph builder. All right, and then we choose the box plot, the type of the plot we want, and then we just drag the variables into the job zones. So we want the bedrooms as my x variable, and then my house price will be my y variable. All right, so this box plot will show much more clear than the one we had before, right? So we have kind of linear relationship. Okay, so this is how to get the graph, but to get the simple linear equation, right? Simple linear regression equation, we need to fit the data. So we still need to use this scatter plot and then say fit the line, right? So this is the output, and we should be very familiar with these outputs right now, right? So the first line here will be the linear fit. So we have the price equals this much plus this much times that, right? Okay, so let's come back to our we say we call it is simple linear regression equation, right? So what is price hat? It is y hat, right? Equals to this is b0 plus this is b1 times x, right? Okay, so what does this mean? It means, okay, when you do, if you want to interpret the b0, theoretically we say if there's no bedroom in your house, then the price of the house will be this much. But does it have any practical meaning? Is that possible that a house doesn't have any bedrooms? No, right? So for this case, B0 doesn't have the practical meaning because of the extrapolation, right? So again, how you interpret this B1? We say we have one more bedroom. The price of the house is expected to be increased by this much, right? Okay, so what does that mean? That means the price tend to increase if the bedrooms increases, right? So this is our common sense. If a house have more bedrooms, then this house price should be higher, right? So we say since this B1 is positive, right? So we say when the bedroom is increasing, the price of the house will also increase. And then let's look at the output, right? So we say we want to determine whether this model is good or not. We need two information, right? The first one is R square, right? So we say R square is 0.214. That means R square is 21.4%, which is very low, right? We say we expect the R square to be closer to 1, right? So if R squared is just 21.4%, it is very low. That means the model accounts only about 21.4% of the variation in house prices, right? And if you look at the MSE, it looks like very large, right? It means e to the plus 9. That means there are you need to have the 4.683 times 10 to the 9th, right? So that means your MSE is very big, right? So this is also not the one we expect. That means for this case, the simple linear regression is not that powerful, right? Because our regression is not accurate. We cannot just use number of bedrooms to just directly make the prediction about the house price. It will not be very accurate. That means we need to add some other factors into our regression for a more accurate prediction, right? So here we just explore one more predictor, which is the living area size. All right, so we want to add one more predictor into my regression. So how I can do it? Let's look at our data. All right, so we say the price is the Y, no change. But now I want to include the bedrooms and living area into my regression. So I need to add one more living area explanatory variable into my regression. That means I will have more than one explanatory variables will be multiple regression, right? Then if you want to fit the multiple regression, you need to do analyze, but then you cannot do fit y by x because this is only for linear regression. Here you need to use fit model. Alright, so fit model you can use for the linear regression, you can use for the multiple regression. It doesn't matter which one you use, but this function fit y by x only for the linear regression. Alright, so let's say fit model, right? So the price is always our y, right? And now we want to use the bedrooms and also what else? The living area to be my second, not second, they have the same importance, right? So we say bedrooms is the one number of bedrooms. This variable is the one we have already included in our simple linear regression. And then we want to add this living area variable into this regression so that we have multiple regression. All right, and then we run it. Okay. For this regression, we still have 1, 2, 3 tables. All right, okay, so we'll talk about these two things later in the data mining chapter. All right, okay, so we still focus on these 3 tables, and then it will tell you the first thing R square, right? So now R square for this regression, for this multiple regression, is 0.578. Remember what we had before? For the simple regression, we have 0.214. But now we will have the R square change to 57.8%. That means kind of doubled the R square. That means what? That means this multiple regression should be better than the simple regression. The prediction will be more accurate than the one we had in the simple regression. All right, and now let's also look at we say the number of bedrooms and the price show the linear relationship. And let's say the living area and the price, right, to see whether they have the relationship, the linear relationship, right? So just need to check that. Okay, so this is the scatter plot between the living area and the price. It shows kind of strong linear relationship, right? So that is why the R square is getting increased, because this factor, this explanatory variable, increase the relationship between the x and y. All right, so let's look at this table again. Where is our multiple regression table? Alright, so we have totally 1057 houses. The R square is 0.578. That means we have 57.8% of the variation in Y is obtained by the regression. And then this one we'll talk about later, this chapter. And then we just focus on this table, the parameter estimates. Right, so without my introduction, can you read this table by yourself? We have 1, 2, 3 rows, right? The first row is called intercept. So what is intercept? The intercept will be, let's just look at this one, right? So the intercept will be this row, right? Will be about, we talk about the population, right? So this row is about beta 0 intercept. All right, and then we have the bedrooms and the living area, 2 rows. That means we are considering the bedrooms as our variable x1. The living area is our x2. And then this row will be about the coefficient of x1, which is beta 1. And then this row is about the coefficient of x2, which is beta 2. Alright, so now let's look at our output, right? So we'll have the intercept is about beta 0, the bedrooms is about beta 1, and then beta 2. And then we'll have their estimates. So this value, 20,986.094. What is this? This is B0, right? So this is the estimate for beta 1, which is B1. This is B2, right? Okay, and then we will have one more column is their standard error. So this is the standard error of B0. This is standard error of B1. This is standard error of B2, right? And then we can test about each parameter and then corresponding p-value. We'll talk about that later, right? So that means based on this, we can write the equation, right? Okay, so how we can write the equation? We need to talk about the general format first, right? So for the multiple regression, we still need a sample, and then use this sample to estimate the population. All right, and then based on our sample, we still get our, we call sample regression, since it is not linear regression anymore, so we just call it a sample regression equation. For population, we have the corresponding population regression model. All right, so we say for the one explanatory variable, right? For the simple regression, we have what? We have y hat equals to b0 plus b1x, right? Correspondingly, for the population model, we have mu y equals to beta 0 plus beta 1x, right? Okay, but now we have multiple axes. We have x1, x2, x3, x4, and maybe many of them, right? So as many as you want to add into your regression. So the sample regression equation for the multiple regression will be y hat equals to still b0 plus b1. Now this b1 is for x1, and then we'll plus b2 times x2, and then keep continue. For example, if you have k variables, k explanatory variables, then you will have bk times xk. So here we say the k is actually the number of explanatory variables you want to include it in your regression, right? So for our example, we have two variables in our regression, right? We have the living area and the bedroom, right? Okay, and then for the multiple regression, what is the population regression model? Can you write it by yourself? It will be mu of y equals to beta 0 plus beta 1, now corresponding x1, and then we will have beta 2 x2, and then keep adding until the kth variable. Alright, okay, so this will be the multiple regression equation and the population model. So still will be similar. We use y hat to estimate the population mean of y. We use b0 to estimate the beta 0. Alright, we use b1 to estimate beta 1. We use b2 to estimate beta 2. And then maybe others until, for example, bk we use to estimate beta k. Alright, so now let's think about how to interpret each of them now. We say y hat, right? So here y hat, there's no change for this y hat. It is still the predicted value of y, right? So the predicted value of y, but now this predicted value of y is based on x1, x2 until xk, right? So we say the y hat is the predicted value of the response variable based on x1, x2 until xk. Alright, and then what is b0 here? Remember in our simple regression, right? So how you interpret b0? It means when x equals 0, this term will be gone, right? And then the value of y hat will be just a b0, right? So we say for b0 is just a when x equals to 0, y value will be b0. But now this is our sample equation, right? You do not have just one x, you have x1, x2 until xk. So what does this b0 mean? It means when all of these x's are zeros, then the value of y will be b0, right? So we say when x1 equals to x2 until equals to xk, all of them are 0. Then the y hat, which is the predicted value of y, will just be b0. Alright, okay, you see the difference here? So in the simple regression, we only need to take care of one explanatory variable, one x. But in the multiple regression, we need to take care of all the explanatory variables here. Alright, so now let's think about how to interpret B1. We say the B1 is kind of the slope for x1, but actually it is not the real slope, right? We have all other terms. So how you can interpret the B1? Does that mean that when x1 increase by 1, the y will increase by B1? No. Alright, so be careful how you can increase this one and this just increase by that. We have a condition, a conditional on when others for these terms are not changed. Then when you increase x1 by 1 unit, then y hat will increase by b1. Alright, so be careful when you interpret we call them are coefficients, not the slope anymore. Alright, so they are the coefficients. Alright, so when you interpret these coefficients, you need to specify the condition first. Conditional on what? When other variables are all fixed, then when the x1 increase by 1, y will increase by b1. So we say when x2, x3 until xk are all fixed. That means there will be no change for these terms. And then when x increase by 1 unit, the y hat, the predicted value of y, will increase by the slope, which is not the slope, the coefficient b1. So got the idea? When you interpret the coefficients in the multiple regression, the idea is the same, but before you interpret like a slope, you need to have or specify the condition. We need to make sure all of these terms are fixed. Alright, so the same thing for B2. How you interpret B2? Now you want to interpret this term, right? That means you need to fix other terms. That means when x1, x3 until xk are all fixed, then when so here will be when x1 increase by 1 unit, right? So here when x2 increase by 1 unit, y hat will increase by b2. More generally, we say if it is for bk, to interpret bk, then what you need to do? We need to fix all these terms except this one, right? So that means we will have when x1, x2 until the term before the xk, right? So we say xk minus 1 are all fixed. Then we say when x increase by 1 unit, the predicted value of y will increase by bk. Right, so The idea is the same. The only difference is when you interpret the coefficient before each variable, you need to specify others first. Alright, so you need to fix the value of other variables first so that you can interpret this. Alright, okay. Let's look at our example. Right, so this is our parameter estimates table, right? So this we call, this is beta 0, this is B0, this is B1, this is B2, right? And then we say, then we will have, it's still, we call it is sample regression equation, right? So we'll have what? We'll have y hat equals to, this is b0, right, minus this is b1 times x1, and then this one is should be plus, that means b1 is negative, right, and then plus next term will be b2 x2, so this is our b2. Alright, so that means in our case the k equals to 2. We only have 2 explanatory variables in this multiple regression. Alright, and then we'll have the standard error of b1. So this one will be b0, right? So it will be standard error of b0, the same thing. And then we have the standard error of b1, standard error of b2. And then we have the test statistics for each of them, and we have the corresponding p-value. We will talk about that later in next video. Alright, so here will be how you interpret the coefficients in the multiple regression model, right? So in this detailed case, we have what? We have, this is B0, this is our B1, this is our B2, right? So now let's explain the B0, right? So how you interpret this B0? First, the value of B0 is 28986.10. So what does that mean? That means when all these two or both of these two variables are 0, then the house price will be this much. But does that have any practical meaning? No, because there's no any house have 0 bedrooms and 0 living area, then there's even not a house, right? So we do not have the practical meaning because of the actual prediction. So how you interpret B0 in this case? We say theoretically it means if a house has no bedroom and no living area, then the house price is this much. However, it doesn't have practical meaning because of the actual prediction. Alright, so this is the way how you interpret B0. And then how you interpret B1. The B1 is the coefficient before x1, the bedroom, right? So we say how to interpret this B1. First, you need to control the other variables, right? So for this case, that means you need to control the level, the value of living area, right? Okay, so what does that mean? That means if a house has fixed living area, then one more bedroom will decrease the house price by this much. Alright, it kind of have the opposite conclusion with what we did with the simple regression, right? So we say when we have more bedrooms, we kind of have a higher house price. But what happened with this case? with the same data set, we should have the same information, right? But now we say when we have more bedrooms, the house price is decreasing because it is negative. So what does that mean? Remember how we interpret this B1? We have a condition for fixed living area, right? So we say if the living area is already fixed, then if you have more bedroom, what does that mean? Think about it. Does that mean that more bedrooms means smaller and more cramped rooms? Right? Because our living area is already fixed. So this is our fixed living area. It will not be getting larger. Alright, and now, for example, you have 1, 2, 3 bedrooms, right? And then for another house with the same living area, you have 4 bedrooms. For example, you have 4 bedrooms. Which house you will prefer? For me, I will prefer with the 3 bedrooms because I do not want the whole house is full of bedrooms. There's no other free spaces, right? So we say for a fixed living area, then 1 more bedroom will decrease the house price by this much, right? So if you have a fixed living area, then if you have more bedrooms, it would be more crowd, right? Okay, so if I am the house buyer, I would prefer to have the spacious bedrooms, will not be cloudy bedrooms, right? Okay, so this is how to interpret this B1. All right, so that means when we interpret this variable, now we need to consider the other variables. The same thing, how you can explain B2. So first, B2 is 93.84, right? So what does that mean? Again, if you want to interpret this B2, you need to control others, right? So that means if the number of bedrooms is fixed for a house, then every square foot increase of the living area will increase the house price by $93.84. Got idea? So if for a house I have 3 bedrooms fixed, and then if you have larger living area, so of course the house price will increase, right? You have more space for other rooms, right? Okay, so this is how you expand the B2, right? So for both of these 2 coefficients, you need to take care of the other ones, right? Okay, and then the next question, based on this equation, a house with 4 bedrooms with 4,700 square feet of the living area, what is the predicted price for this house? So what you need to do, you just plug in the value of x1, right, which is 4, right? And then the value of living area, which is x2, equals to 4700, right? And then you just plug in the x1 value and x2 value into this equation, and then you just calculate, you will have the predicted value for this much. All right, and then next question, in fact this house would sell at 450,000. Right? Find the residual. Remember what is residual? The residual, we say the residual will equals to y minus y hat. Right? So what is y? This is the observed value, just the information you collect from the real cell, right? And then for y hat is the predicted value based on this regression, right? Okay, so what is the residual for this house? It will be y minus y hat, observed y, which is this much, right? Minus the predicted y will be this much, right? And then you have the residual, which is this much, right? So this residual will tell you how much difference is between what you observed and what did you predict from your regression. We want the residual to be as small as possible, right? We don't want the error, the difference is big, right? We want the difference is small so that we say our regression is accurate, right? Okay, the next one, what does the residual say about the price of this house? We say the residual here is positive, right? So that means our observed value is larger than the predicted value. That means it was sold with a price that is higher than what we expected, right? So it is a good sale, right? Okay. All right. So I will stop now for the general idea of the multiple regression. In next video, we will talk about make the hypothesis test for the regression. All right. Okay. So see you in the next video.